This video is a short overview of the ExcSim Reservoir Simulator, which is an add-in to Excel. Everyone uses Excel, the Microsoft spreadsheet application. And ExcSim is a COM add-in that features a fully implicit two-dimensional reservoir simulator in 3 phases: oil, gas, and water. And oil comes both as a liquid and as oil vaporized in gas, like a condensate. And gas comes as free gas and as gas dissolved in the liquid oil. The model can consist of over 1,000 grid blocks arranged in a 35 by 35 model. If you don't have PVT data or SCAL data, ExcSim also comes with correlations that will generate PVT data and SCAL data, relative permeability data, and capillary pressure data for you. And also to describe the geological structure, if you don't have it in numeric terms as a grid, ExcSim also comes with the possibility to contour, to draw the lines on a contoured picture and digitize it and actually generate the structure grid for you. And you can populate it with permeability and porosity variations, heterogeneities if you like, and include faults and partially sealing or completely sealing barriers in the normal sense. So when you install ExcSim and open Excel, at the very top of the menus here you'll see an ExcSim tab. And the first time there won't be much there. You'll have some information about your license, your name, and the user code that has been assigned to you. It's unique to you. The first thing you need to do is to register ExcSim, and you do that by clicking here on this side and entering your name and email and the user code, which is the user code is this part right here, right underneath your username. And you enter your user code here and your order confirmation number that you received from, I guess, from PayPal. Once you submit that, you submit it by pressing this button. Once you've filled it in, you will receive a license code from us. And once you receive the license code by email from us, you'll go here and you'll say yes, you received the release code, the license code. And I've copied it and I'll just paste it here. In my case, this is my number. And once I do that, you'll see that you'll have a new expiry date here. But still, there's not much you can do with ExcSim. You first need a model. And you can generate, or you can load a template model by clicking the new Sim tab here. What happens is it'll load a new Excel file that actually is a running model. It has everything you need. All you need to do is push the run button, and it will start to run. You can view the model here. In this case, this is a Uh, this is just a template. Of course, you have to go in and change the model to fit your needs, uh, but it's here. Here's the saturation with water, oil, and gas, a sort of ternary plot. And you got permeability, the top map, uh, porosity, etc. If you look at the bottom of your sheet here, you'll see there are three green worksheet tabs at the bottom. All the green ones are input uh, sheets. If you click on the green on the grid, you'll see the grid data at the top of the worksheet. You'll see the top map here. I'm going to zoom out a bit so you can see all the input for the grid. At the first one is the top structure. Then the next array, 2D array of grid cells contains the thicknesses of each grid block, then permeability, porosity, and transmissibility multipliers in the x direction, in the positive x direction, and in the y direction. Now, what I mean by positive x direction multiplier is if I put a 0 transmissibility multiplier there, it means that there will be no flow to the right from that point, from these grid blocks, to the neighboring grid blocks. Uh, but let's go back to the top of the screen here, where the top map is. Uh, Never mind the colors. You can change the colors by selecting a different uh, conditional formatting or whatever it's called. At the top here, you got the top map, in this case in feet. This part represents the 35 by 35 grid block model with 35 grid blocks in the x direction going horizontally and in the y direction shown north-south here on the worksheet. Along the edge of the matrix, you'll have the dx values, uh, which is the dimension of or the x dimension of the grid blocks. And vertically, you got along the edge, you got the y dimension of the grid blocks. And in the matrix itself, it's the depth from the surface down to the top of the structure. Uh, the next range is the thickness of the layer. Here, this part, again 35 by 35. Every grid block has a thickness, and permeability follows next, and then the porosity beneath the permeability, and then transmissibility multipliers following that. So going down to the bottom here, the second input worksheet is the PVT and RelPerm sheet, and you enter the oil PVT data here, the gas, and the water PVT, and over here you got the oil water RelPerm and capillary pressure, and gas oil relative permeability and capillary pressure. Also, I want to mention that you got the surface densities of fluid, of oil and gas and water, and the pore volume compressibility, the rock compressibility. here. These are also important input data. If you're familiar with ExcSim, the PVT input to ExcSim, and in particular the PVTO keyword, ExcSim follows the exact same format. And if we look at the oil PVT, it's divided into segments, sections, for each GOR or R sub S. Here's one with that RS at 0.28. 0.35 has this section, 0.42, etc. And within each section, there's the first line is the saturated data, the saturation pressure for this particular GOR, and the formation volume factor and viscosity at saturation point. Immediately following the saturation line, this is the saturation line, the next data here has undersaturated data. The pressure is higher than the saturation pressure, and associated with the higher pressure you have a different formation volume factor and different viscosity, oil viscosity. The next table, the gas table, is the PVTG keyword from ExcSim. It's the same format, and it's very similar in philosophy to the oil PVT. You got these different sections, and the first line is the saturated, and any other lines are undersaturated. And you have the water PVT data with pressure, water formation volume factor, and water viscosity associated with the pressures. When it comes to oil relative permeability, oil water, you have first you have the water saturation, then the associated water relative permeability, and the associated oil relative permeability in the oil water system, and capillary pressure. And then you have the gas oil rel perm, which is similar. If you don't have data here, if you don't have fluid data from a PVT report or from a fluid lab, ExcSim comes with the PVT correlations, where you can enter the reservoir temperature, separator temperature, etc., nitrogen, CO2, H2S, and salinity, and the fluid densities, and generate PVT. I'm going to generate a range, gas or R sub S GOR range from 0.28 to let's say 0.6. Oh, sorry. This one to 0.6. This one from 0.2, say, and up to 7,500 psi. I'm going to have 5 saturated points, saturated sections, and 3 lines, or say 5 lines of undersaturated data in the table. So here you got the 5, 1, 2, 3, 4, 5 saturated sections, and 1, 2, 3, 4, 5 undersaturated lines or data points within each section. Similarly, there's a input for the relative permeability, the SCAL data. If you don't have a SCAL report, You can generate rel perms and capillary pressures using standard correlations, the Corey exponents, the endpoints, etc. And also the size. Say you want 25 lines in the table, you can press the scale and generate your tables here. The last input sheet is called wells and controls. And here's your well data, where you have the well names in this column and the I location for each well, the column of your grid, and the row, the J location, which specifies the grid block, and the wellbore radius, skin, the maximum rate, and the production fluid, in this case oil. These are oil wells, but you could have gas wells if you want. And minimum bottom hole pressure, maximum gas oil ratio, maximum water cut ratio, and these blue columns are only for injectors. And then finally you've got open and close date, when the well opens and closes. You will need to specify either a maximum rate or a minimum bottom hole pressure, or both. But you can't leave them both blank. You have to have pressure data in one of them. So this is okay. Here's that well has both of them. This one has a bottom hole pressure. That one does not have minimum bottom hole pressure, but it does have a rate, and so on. Here's the injectors. The first two are water injectors with a fixed rate. Here again, either you have to specify the rate or the maximum bottom hole pressure, or both, but at least one of them, and a startup date and a closing date for each well. In this case, we got 4 producers, oil producers, OP1, OP2, 2 water injectors, and 1 gas injector. And if you look at it from the 3D viewer, you can see the 4 oil producers here as black wells, and the injectors, the 2 water injectors here in white, and the gas injector in white. And you can see their location. You can move them around. And, to initialize the model, you need to specify where the gas oil contact is, and the water oil contact, and the datum depth and datum pressure. And then you run the initialize, and it'll initialize the model and calculate exactly where the gas oil contact is and water oil contact, and you can see it here in the output map, the pressure, saturations, etc. To control the simulation, you specify the maximum time steps, the maximum time step size in days, hours, minutes, and seconds. You also specify the maximum number of iterations you want to do while searching for convergence. And if it doesn't converge, then it'll cut the time step by, in this case, the time step factor, which is 2. You can put whatever you want, 1.2. So that's the maximum iterations. The tolerance is the total material balance error that is tolerated for each time step, which is 1 in 10 millionth. It's kind of an average saturation, There's a tolerance for oil and one for gas and one for water. Each of them have to pass the tolerance check. And in terms of material balance, it's a very strict uh, requirement here of 1 in 10 million. You can change that, be less strict or even more strict. In addition to the total global material balance acceptance limit or tolerance, each block has its own individual tolerance limit, which in this case is 0.1%. Uh, and the first time step of the simulation is set to 1 hour, and it'll increase, once it converges, it'll increase the time step by a factor of 1.2 until it reaches the maximum time step of 30 days. And it'll also chop the time step by 1.2 if it doesn't converge. So with that, all you have to do is push your run button, and you can look at the oil production. In this case, we got oil, the total field production at the top here in blue. It's producing 6,000 barrels a day because it's only the first well has started. Uh, you can see that the simulation now is in August. It's making 30-day time steps. Now it's December. Okay, now the next well will come in. This one does not have a max rate, but it does have a minimum bottom hole pressure. So it'll flow as much as it can, but then gradually, as the pressure drops around that well, the flow rate will also drop. You can look at the gas oil ratio. Seems like there was a dip in gas oil ratio, and then it came up, and then it dropped again when this new well with cleaner oil came in. The third well. You can also look at the cumulative oil production here. We're approaching 11 million 11 million barrels of oil. And you can look at the individual oil wells. Let's see, we've got three wells have started so far, and you can see their individual rates. Here's the first one, there's the second one, there's the third one, and the total field looks like this. And also you can see that the gas cap is coning down to these three wells. You'll also see that water seems to be coning up here. Just give it time and see what happens in the end. I'll stop this recording right now, and I'll come back when the simulation is done. Okay, I'm back, and the simulation has finished. We have completed 30 years of simulation, and we can have a look at the results here. What this plot shows, you can turn on and off the 3D effect here. I've chosen the field production. You can by ticking off the field production, and I want to see the oil rate on the left axis and the cumulative production on the right axis. I can switch to water cut in this case. I can add the individual wells, OP1, OP2, OP3, and OP4. These are all the individual wells. Let me turn off the total field production, and let me turn off the 3D effect so you can see the individual wells. Just look at the oil rates here, and we can add the water rates here. We can plot the gas rate on the right hand axis here, etc. I'm going to close that. Also, I want to show you the 3D viewer, where here we have the saturation distribution. And I'm going to go back to the beginning. This is the first time step in 2020, January 1st, 2020. And as we progress through time, you can see the water cusping in, the coning in, and the gas cone developing. And as wells shut in because they water out or the pressure drops, you can see the dynamics going on here where this well sucks up all the gas more or less. So in addition to and there's a material balance thing here too where you can see this is the offtake in reservoir barrels, 500 million or whatever, oil, gas, and water, and the contribution from each of the drive mechanisms, the aquifer, gas injection, water injection, and gas expansion. In numerical numbers, here's the production profile, the time steps from and to, from that time to that time. You have this oil rate for the total field production, water rate, gas rate, cumulative oil, cum water, cum gas, and there's also a total field injection part here that shows the water injection and the gas injection and the cums, and then followed by each individual well. You see all the wells are listed here. In addition, you have the saturation output. You have, in this case, the initial pressure here. This is the current pressure, here's the current pressure for any given time step during the simulation. And to the right here is the difference between the initial and the current pressure. And you can see where things are happening, how the pressure changes. Also, you have the initial gas saturation here, and the current gas saturation, and the change in gas saturation here, and in water, and in oil. So you can see that there's been a large influx of water all around it, and also gas has come out of solution, and the gas cap itself has tipped towards the northeast there. So yeah, that's basically what I was planning to say in this general overview of ExcSim. I'll come back with more specific videos later on, but for now, thanks for watching, and I'll see you back again here pretty soon. Bye-bye.